Hi, my name is Eduardo Ox, and the title of this video is Learning Git with Triads and EEV. I'm the author of an MX package called EEV that most people find hard to understand, but its tutorials has lots of things to try and lots of examples. And when people start running the examples, they sometimes they feel that everything makes sense. Whatever. Let me start with a bit of context. A few weeks ago, in December of 2023, something broke in the scripts that I used to update the Git repository of EEV, and the part that kept the two branches of EEV in sync stopped working, and I had to merge the two branches many times. I'm very bad with merging. Each merge took me hours and put me in panic. I was very afraid of doing wrong things that I wouldn't be able to undo later. By the way, I'm very bad with Git, and I'm good with programs that let me do small reproducible tests, and preferably in REPLs. A few years ago, I tried to create a way to learn Git using REPLs and reproducible tests, and I felt that it was time to work on that again. And by the way, about this figure here, my presentation at the last MXConf, the MXConf 2023, was called REPLs in Strange Places, Lua, LaTeX, LPEG, LPEG-REX, and TIX. And this figure here is part of an animation that I did using these techniques in TIX. And the full animation is here, and it shows how we can create a complex Git repository with several branches and with a merge here, step by step. So these things show the names of the commits, the graph of the commits, the branches, how the branches move from one commit to another one. The red dot here is the head, whatever. Anyway, the focus of this presentation is on the triads. Let me run this thing here to activate screen key. So now people can see the keys that I'm typing here. And let me show the triads. Note that I have EEV installed, and I have this indication here that EEV mode is active. If we click on that with mouse 2, it shows the main keys of EEV. Let's go to this sandbox tutorial. That is the tutorial about Git. That is what I'm going to show today. It lists some prerequisites here, but whatever. The introduction starts with a mention of a tutorial on Git with a free license. It suggests that we download this thing here using brep, and brep is explained here. The idea is that we can put the point here, type metax brep, and then it will show a temporary buffer with a script for downloading a temporary copy of this PDF. Done. And now we can execute these two sexps here to define short hyperlinks to that PDF. Let's take a look at that PDF. Note that it has several figures here. For example, this figure here that shows the head. The circles are commit objects. Triangles are tree objects. Squares are blob objects. And then it has diagrams with another shape and other conventions. Then similar diagrams, but with a more complex structure. Then here's another thing. So several kinds of diagrams. And here they even have colors. Anyway, let me go back. This is a diagram that is going to be very important for us. This is a diagram that appears in one document that comes with Git. It's called Git Revisions. If I open this month page here, it is here. Note that this link here not only opens this month page, but also searches for this string in that month page, so it goes straight to the middle of the month page. And here the month page says, here is an illustration by John Lulliger. And I'm going to refer as this kind of diagram here as a Lulliger diagram. This is not the official name, of course. So this is the Lulliger diagram. For me, it's the canonical example of a Lulliger diagram. And things that are similar to this one, I will also call them as Lulliger diagrams. And we saw here how this Lulliger diagram with the names of the branches can be created step by step. So this is the final Lulliger diagram of a certain Git repository, and the other Lulliger diagrams show intermediate steps of how to create a Git repository with that structure. Oops, sorry. We are here. And in this tutorial, in this intro here, find-git-intro, I will explain a way to create a Git repository corresponding to this Lulliger diagram here, and a lot more. Let me first show something that doesn't have any prerequisites. I mean, if you have EV installed, then you probably know how to turn on EV mode, which is this thing here. If EV mode is on, then F8 is going to do this. It either sends the current line to another Emacs buffer or executes the current line if it starts with a red star. My example with no prerequisites is in this page here. So here we have an animation of how that Git repository can be constructed. And here we have this block here that is an AAPH block. You can just copy and we can just copy and paste this thing here to an Emacs buffer, and if we execute this thing, these bullets here behave in exactly the same way as the red stars. So if I type F8 here 3 times, it creates a target buffer here running bash. Note that it says bash here and it says bash here. And now if I type F8 on the other lines, the lines will be sent to the target buffer as if a user were typing the lines one by one. So here at the beginning I define an environment variable called n and several shell functions, and then here I initialize a Git repository, and then I give these comments here. Note that the comments they modify the file one several times. They have several commits, they create new branches, they switch branches in many points, and there's this obscure command here that merges two branches. And if we execute this sex here, it will show the result. The result is in this directory here, /tmp/eev test1, and this will run git k on that repository with certain command line options. It will show that the contents of that repository is this. This is the same tree as before, but displayed in a slightly messier way. So this was the first example, one in which we just have to copy this thing here to NMX buffer, and then execute this thing with F8. Now let's see the examples that are in the here in find-git-intro. This section 1 shows some preparations that we need to run. We need to check that we have bash, git, and git-k installed. Then we have to run these things here, just to make sure that we have copies of two files, and that the copies in this machine is the same as the upstream copy. After getting these two things, we can run these things here to access a PDF with a flipbook animation, in which each page is a frame of an animation here. By the way, if you want to understand what these things do, the trick is that you just have to duplicate these lines and add a find at the beginning of each function name here. So instead of code PDF page and code PDF text, we will have find code PDF page and find code PDF text. And if we execute these things here, for example, this one, it will show us a temporary buffer that explains what this version here would do. So this does something, but does not show us what it is doing, and this explains what this thing here does. We also need to run this thing here to access a local copy of my library of shell functions. Remember that here I defined several shell functions, and then I used those shell functions to to create a certain Git repository. Now this section here visits that library of shell functions. It is here. Here we have an index. Here we have those shell functions and a few others. Here we have basic tests that explain what are these basic shell functions here. And by the way, this thing here is something that is very interesting. It's something that I call a test block. If I type metax EEIT, this will insert a test block at the current point, and the syntax of the test block depends on the language that I'm using. So here is we are editing a shell script, and a test block has this funny format here. This thing acts as a multi-line comment. So for the shell, this thing is a multi-line comment, but for me, this thing is executable with F8. If I put the point here and type F8 several times, it runs some tests that sort of explain these definitions here. So here we have a section with basic commands and the tests for these basic commands. And then we have a section with this big function here, make3one, and then some tests for make3one. This is these three in an ugly format. And note that in this test here, we created a tree with this shape here. And now we have some extra things here. These extra things here are some examples of how to query the data structures of that repository. For example, if I ask Git to show what is the head in this case, it will show me that the head is this thing here is a commit with this author, this date, and so on, this message, and the contents of the commit is this thing here that is being displayed as a div between the repository in a certain moment and the repository in another moment. If I run this thing here, if I ask Git to show what is the file1 in head, it shows the file in another format that is totally different. It's not a diff, it's just a, it looks like a normal file, not a diff. And I can also run these things here to inspect all the data structures. And these things here in comments, ways of accessing the documentation of some things that are here. So for example, I used show ref here. The docs of Git that come with Debian come in many formats, so I usually prefer to be able to choose between all formats when I want to inspect. For example, to get more information about show ref, I can run this thing here, and it shows me ways of accessing all these formats. For example, this thing here opens the man page converted to txt. This thing here opens the man page itself, so it has boldface, underlined, and so on. This thing here shows the man page in HTML, and this thing here asks Git help to show me the help about show ref. So we have here we have a big shell function and also an export here, and here we have the tests for this big shell function and some other tests that I decided that this was the best place to put them. So note that here we just saw how to run the tests that are in this file here in test blocks. This test here in find-git-intro is essentially the same thing as before. Oops, sorry. Sorry, I deleted this thing. Okay, now I had deleted the copy of ev-gitlib1.shell in /cmp, but now these things are going to work, I hope. Yes, so it created that big tree. This is it shows the tree in a certain ugly format. Now I can ask git-k to display that tree in another ugly format, but with more colors. Here it opens my flipbook animation in the final page that shows the tree in another format. And so this explains the first test. And note that here this thing has several pages, and the pages has some labels here. What are these labels? Let me explain that, because this is something that I wrote a few days ago and I found very interesting, very useful. Let's go back to this file here with my shell functions and tests. Note that here we have the index, and at this moment the final block defines things about time that are comments for recording how a repository changes through time. It has pointers to the flipbook animation. And the idea is that a command like this one, time 420 in a script, means it's 420 now, or at this point of the script, the timestamp is 420. Or if we think on that as an action, the action means take a low resolution picture of the Git repository and save it in the file /tmp/evgit underline 420. So in this test here, I will run something very similar to this big function here that created these three here. But now my new version of that, let me open the old and the new version side to side. The new version has more columns, and it has timestamps at many points. For example, this point here is going to be the timestamp A0, this is the timestamp A1, timestamp A2, and so on. So each one of these things takes a low resolution picture of the repository at that point. The low resolution picture is just a tree of generated by git log. And all these low resolution pictures are saved to files with certain names, and then at the end I can run this thing here, timeline, that concatenates all these files. So let's run that. Now if I run timeline, it generates all these trees here, and this line here does the same thing, but it also generates a file called /tmp/all. Now that we have that file, we can use that file to see how the repository changes at each point. For example, we can now we can understand what happens when you create new commits, in the sense that some tags are going to be moved to the new commit, some tags are not going to be moved. I found the rules very hard to understand. I mean, when I was able to draw the diagram, then things became much simpler, but just by reading the rules and the manuals, I found them very complex. But so when I started studying this diagram here, the rules started to become clear to me, and when I found a way to translate that diagram to the other format that is much prettier, then things become much clearer. So these diagrams helped me a lot. So this section here is about how to create timelines and how to inspect all the files that were created. Note that here we have the individual files, and then these files were concatenated into this thing here called all. And here's one application. Now that we have reproducible tests, it should be possible to use these reproducible tests to create a tutorial for Magit. This EEPitch block here creates a very simple repository in /tmp/evgit-test2, and this repository has 2 commits, and then I modify one of its files, file 1, and my shell functions do not create a third commit. And if we use if we run Magit on that repository, by the way, if you do not have Magit installed, then you can either install it in the usual way, or you can use this thing here and install it in the EEV way. You may need this thing here to configure Melpa, like running these and these. And then you can execute these things here: package initialize, package refresh contents, and package install. And then you will have Magit in your machine. Anyway, I do have Magit here. Let me run this thing here, it runs Magit on that repository that I just created that has an uncommitted change. Magit will save that we have unstaged changes. Then I can type uppercase S to stage all these changes. Then I can type lowercase c to commit the new change. Then Magit will ask me to write a commit message here. Let me write a very simple message like blah here. And then I can type Ctrl+X # to save that commit. And now it says that the head is in that commit here, whose message is blah. So I'm changing styles here. Up to this point I was doing everything with just shell commands, and now I'm using this thing here to create the basis for learning or for practicing Magit commands. So I just instead of creating a commit by running commit C or commit blah, I did that from Magit, and it should be possible to use that to create a tutorial for Magit that will explain some operations that most people find difficult, or anyway, or at least the people like me find them difficult. By the way, these are links to the manual of Magit. This is the part that explains how to use uppercase S to stage changes, and this is a link to the part that explains how to create new commits. And again, I found these things very hard to understand when I started to learn Magit. And now here we have a section about why this and about anyway, let me read this. I found Git and Magit both very hard to learn. To test most concepts, we would need a repository with tags and branches and a second repository that pulls from that. And even with that, most tests would be very hard to undo and to reproduce. And when I was trying to learn Git, more specifically, I was learning Git to try to set up a Git repository for EEV, my package. When I was trying to set up a Git repository for EEV on GitHub for the first time, I did several things wrong on the GitHub side. And I didn't know how to fix that. I didn't know how to undo these things. And after spending several days trying to fix that, I gave up. I deleted that repository. I created a new one, and I decided that I would be very coward from that point on, because I didn't know how to undo certain things. And I decided I would always do lots of local tests before messing up my public repository again. So at that point, I started playing with the idea of reproducible tests and not committing everything to a repository in GitHub. And this is my nth version of my tools for doing lots of local tests. And of course, if you like this approach, then please get in contact. Let me show another example of something that the tutorials suppose that... Anyway, no, sorry, let me explain it in another way. A typical use case for Git is like this. There's a shared Git repository in a server, and there are several developers, each one on a different machine. And the developers are working on copies of that shared repository, and they are making changes on that, and they are trying to somehow synchronize their work. So they are going to save their changes to their local repositories, and then they are going to push those changes to the server somehow. And I found the tutorials suppose that you are one of the developers and that you are working with colleagues on that shared repository. But I couldn't find easy instructions for creating that server repository or for creating that on a local machine. So this is my attempt to fix that. This is a minimal version, a miniature of how to create the server and the developer machines. And instead of using several machines, I just use different directories in /tmp. So let me type F8 several times. This first block here copies my library to /tmp and loads the functions in ev-get-lib1.shell. This block here creates a shared repository that is going to play the role of a server. The second block creates a directory that will play the role of the first developer. This block here, in this block here, the developer one creates two commits and pushes them to the server. So commit A and commit B, and then git push. And then now we create a second directory that will play the role of a second developer. So now we are going to have three repositories, one ending with S, that plays the role of a server, one that ends with 1 that plays the role of the first developer, and one that ends with 2 that plays the role of the second developer. And now here the second developer creates a new commit and pushes that commit to that repository. And that's a new commit that the first developer doesn't have yet. So now we switch to the first developer. We just switch to this directory here instead of switching machines, and we run git pull. So this is a miniature that probably can be used in the future, say, to show how to do these things with Magit. I mean, we probably can use that to teach people how to do pulls and pushes with Magit. I haven't done that yet. So yeah, that's it for the moment. So a few ideas are already implemented. We have some basic tests here. All the triads should be very easy to try. But I only have one small section about how to use that to teach Magit. To do things with Magit, we have to create a repository, preferably in a way in which this creation mechanism is easy to run again. And then we have to teach people what are the keys that they have to press in Magit. For example, here, for staging the changes, people have to press S in a certain part of the Magit buffer, and then they have to type CC in another position of the Magit buffer, so it's a totally different interface. So this is a prototype, but again, if you like this approach, please get in contact. And that's it. That's what we have now. Yeah, that's it. Bye. Thanks.